Hi guys, welcome back to another video. Today we're going to be going over the following problem that tests our knowledge of basic algebraic identities. And so let's start with a quick read. So if x and y are positive numbers, where x minus y is 12, and the cube root of x minus the cube root of y is 2, find xy. So this problem, at first glance, it's a very straightforward problem, right? This is just a straight system of equations, and we are asked to find the value of xy. So with this, you're just going to have to do some manipulation of the equations given to solve for your right answer. And now one option is always to say, okay, x is equal to 12 plus y, and then plug that into the second equation, and you'd have nasty cube roots where you could cube equations and all of that. And that is a possible solution, but that takes a lot of time and it's a lot of calculations. So we're going to look at a much cleaner, much neater solution. So we know x minus y equals 12, and the cube root of x minus the cube root of y is equal to 2. Now, what's a simple operation I could do to get from cube root of x minus cube root of y to x minus y? So if I cube this equation, right, if I cube both sides, I'll at least have an x minus y, and then I'll have some other terms, right? Sorry, so we'll start again. So x minus y is 12, cube root of x minus cube root of y is 2. And again, we want to just do we want to find xy. And so x minus y is 12, and cube root of x minus cube root of y equals 2. So what we could do is cube both sides of the equation, right? And what that does is it will give us x minus y plus some additional terms, right? So let's do this out. And what do you get? Let's see. So we get x, and we have minus 3, right? So cube root of x cubed, that's just x. Then you have minus 3 times you have the cube root of x squared times the cube root of y. Then you have plus 3 times the cube root of x, cube root of y squared, and then you have minus y. So let's shift this over. This is equal to 8, right? 2 cubed is 8. And this is just an identity that you're going to want to memorize before your competition, right? And let's write this in a little neater format. We get x minus y. Then if we factor out minus 3, we get cube root of x squared, cube root of y, minus cube root of x, cube root of y squared. And this is equal to 8. And now I could further factor this, right? So this expression inside the parentheses, I could just write as the following. Notice we have a cube root of x, cube root of y in both terms. And then I'm left with cube root of y minus cube root of x. And all of this equals 8. Okay, so now, the original problem, we know x minus y is 12, okay? So we could fill that in right here, because we have x minus y right here. We get 12 minus 3 cube root of xy. That's the same format, or just different format, same thing though. And now we also know that cube root of x minus cube root of y is 2. So that means that the cube root of y minus the cube root of x is negative 2. And so this is equal to 8. And now the solution might be clear, right? Because basically I'm left with 12 plus 6 times the cube root of xy equals 8. 6 times the cube root of xy equals 2/3, right? Or sorry, not 2/3, that is division. Negative 4, which means that the cube root of xy equals negative 2/3. And now if I cube both sides, what do you get? You get xy equals negative 8 over 27. And so we find that this is actually our final answer. And so if we go back to the question, they asked for xy as a common fraction. So we get negative 8 over 27. And that's all. So the key with this problem is to realize that we never actually had to find x and y individually, right? A lot of times, if you notice that the question is asking you for some expression, right? In this case, they're asking you for x, y, not specifically x or y, then that could be a hint that you might not need to find x and y explicitly, and rather just find that product, right? And you can see that just knowing your basic manipulations, knowing this cubes, right? How to cube a binomial or anything like that, it obviously came in handy here, because this looks very complicated, but at the end of it, it's pretty straightforward, right? You just want to make sure you don't lose any of your variables anywhere, but it comes out to a pretty nice solution. But regardless, that is our answer for today. So if you have any questions, be sure to leave a comment, and if you enjoyed the video, like and subscribe, and we'll be back again with another video. Thanks to everyone for joining.